Hey everybody, this is Ms. Faina. Today we're going to be talking about exponential functions and the application of them. So looking at our first example, it says there were 235 cupcakes sold at a new bakery in the month of July. Since then, cupcake sales at this bakery have increased at a rate of 3.45% per month. At this rate of growth, which exponential function can be used to determine the monthly cupcake sales in months after July? So if we look at the first question, it says, are we looking for a linear, quadratic, or exponential function? Well, in our word problem, it tells us which exponential function can be used to determine the monthly cupcake sales. So we're looking for an exponential function. Not sure what that did there, so let me fix that. There we go. Okay. Can you read the problem and find the starting or the initial amount? So I'm going to go ahead and highlight that, the starting or the initial amount of cupcakes. Well, right here it tells us there were 235 cupcakes sold. Okay, so remember when we're talking about exponential functions, we have the formula y equals a times b to the x power. So our initial amount is A, which is going to be 235 cupcakes. Can you read the problem and find a word that tells us that our B value is going to be greater than 1? So I'm going to highlight that in a new color. So again, our B value being greater than 1, well, that means it's growth. And it tells us that at this rate of growth, right there, okay, so it tells us that we're going to have growth, which means that B has to be greater than the number 1. So, do you have enough information now to eliminate answer choices? Well, let's take a look at our answer choices. I want to start with B. If you notice, B and answer choice D do not have an exponent of M in this case, okay, because it tells us our variable is M for months right here. Okay, so it does not have a variable of M as an exponent. So therefore, B is going to probably be linear and D is going to be linear as well. So we can eliminate those two answer choices. Now, if we look at the answer choice A and C, we want A to come first, which is 235. So if you look at that, that's going to be answer choice A. Now, how did we get this answer choice? Well, the part that is inside, notice it is bigger than 1, and it's showing growth. Okay, if we take a look at this percentage right here, what we did is we moved the decimal 2 places to the left, 1, 2, oops, and we got the new decimal of 0.0345, and all we did was add that to 1, and we got 1.0345. Okay, so that's how we got the number inside the parentheses. Now, the next question says, how many monthly sales would the bakery expect in November? Well, remember, M is the number after July. So after July, we have August, September, October, and November. So November is 4 months after. So what we're going to do is we're going to take the equation from answer choice A, and for M, we're going to plug in 4, and then we're going to just type it into our handy dandy calculator. Remember, 4 is the exponent. Okay, so I'm going to go ahead and switch over to my calculator, and I just want to be in the calculator part of the calculator. Okay, so here we go. I'm going to type in our handy dandy formula. So we have 235 times 1.0345, my exponent of 4, okay, and then I press enter. So when we do that, I get 269.147. Now let's think about that, okay? So we get 269.147. If we're talking about cupcakes, can we sell 1/10 of a cupcake? Or a partial amount of a cupcake? No, we can't. So therefore, we need to round to the nearest whole number. So we're going to say in November, because this is just a 1, that we're going to expect about 269 cupcakes to be sold. Okay, so just remember, we can't have a partial amount of cupcakes. That's why we round to the nearest whole number. Looking at example 2, the population of a rural county has been decreasing at an annual rate of 3.92%. When the decline began, the county's population was 1,477. Write an exponential function that can be used to find the county's population after X years. So are we looking for a linear, quadratic, or exponential function? Well, again, we're looking for an exponential function. Okay, can you read the problem and find the starting or initial population? So I'm going to highlight that again. It says, when the population began to decline, the county's population was at 1,477. So our initial amount, A, is 1,477 people. Can you read the problem and find a word that tells you that the B value should be between 0 and 1? Well, it tells us that it's decreasing right here, and that it's declining. So that tells us right there, which means our number's between 0 and 1. So let's take a look. Okay, again, remember our kind of generic formula is y equals a times b to the x power. So we're looking for x to be the exponent, so we can eliminate answer choice C. Okay, then we're looking for a, the initial amount, to be 1,477. So we can eliminate answer choice A because that starts with 0.9608. And then if we look at answer choice B and D, okay, the only differences between them is that middle, or that number that's inside the parentheses. Okay, well, we want it to be between 0 and 1, which means we can eliminate answer choice D because it's bigger than 1. So this would be our equation that represents the situation of the county's population declining. Now, what would the population of the rural county be after 3 years? All that means we're going to do is plug in 3 for x. So I have 1,477 times 0.9608 to the third power. And then I go to my calculator and I type it in. So I'm going to go ahead and type in that equation. So 1,477 times 0.9608 to the third power. Press enter. And I get a lovely decimal, 1,310.02. Okay, if you think about it, the number did go down, so that is showing a decrease, which is what we wanted. Okay, and again, we can't have partial amounts of people, so I'm going to round to the nearest whole number. So it's going to be about 1,310 people. Okay, so there's just some practice of identifying the equation that goes with the word problem for an exponential function and evaluating. If you have any questions, please don't hesitate to ask your teacher. We're here to help you. Other than that, have a great day, Rangers.